Let's simplify this expression. So we have a numerator expression as well as the denominator expression. So basically we have to first simplify the numerator and the denominator expression. If you look at, we have 1 by b squared plus a squared. And this a squared can be written as a squared divided by 1. And similarly, in the denominator, we can write down this p squared as p squared over 1. Now let's simplify this numerator expression. We have to find the least common denominator of b squared and 1. Least common denominator of b squared and 1 is b squared. And this means we have to multiply the second fraction by b squared. So you can write down this as 1 by b squared plus a squared by 1 times of b squared divided by b squared. And similarly, for the denominator expression, we have to multiply by the least common denominator a squared. So this is a squared 1 by a squared. The second term I'm going to multiply by a squared and divide by a squared. Now let's further simplify this. So this gets simplified to 1 by b squared plus a squared times b squared is a squared b squared divided by 1 times of b squared is b squared. This is the simplified, this is the expression in the numerator. We will simplify the expression in the denominator. We have 1 by a squared plus b squared times a squared. We can write down this as a squared b squared divided by 1 times a squared is a squared. So now we can see that we have the common denominator of b squared b squared. So this can be simplified as this equals 1 plus a squared b squared over b squared. This is the expression in the numerator. And the denominator, we also have the common denominator, that is a squared, which means we can add the numerator parts. So therefore, it will become 1 plus a squared b squared over a squared. Now let's further simplify this. So we have a numerator fraction and denominator fraction. So here I write this numerator fraction as it is. That is 1 plus a squared b squared by b squared, and then multiply by the reciprocal of the denominator fraction. I have to multiply with its reciprocal. The reciprocal is a squared by 1 plus a squared b squared. You can now see that these two are like terms. We can simply cancel them. So these two terms gets cancelled, and finally we are left with the expression a squared over b squared. And this means option D is correct. We now determine the equation of the line through these 2 points. So we consider the first point as x1, y1, and the second point as x2, y2. So the first step in finding the equation is to determine the slope. And we use the slope formula. This equals y2 minus y1 over x2 minus x1. So we plug in the y2, y1, which is 6 minus 3, divided by x2, x1 is negative 1 minus 5. So this is equivalent to 3 over negative 1, negative 5 is negative 6. And we can simplify this as negative half. So this is the slope of the line. Now we can use the point slope form to determine the equation of the line through these 2 points. The point slope form is y minus y1 equals m, which is the slope of the equation, times of x minus x1. So basically this is m. So let's substitute the x1, y1 and the slope. X1, y1 is 5, comma 3. So y minus y1 is 3. And this equals slope is negative half times of x minus x1 is 5. We'll simplify this. So y minus 3, this equals, I'm going to distribute this negative half into the terms. So negative half times x is negative half x. And negative half times 5, negative 5 is positive 5, 2. We then add 3 on both sides so that we get only y on the left side. So therefore this becomes negative half x plus 5 by 2 plus 3. We add this two numbers, that is 5 by 2 plus 3. We can consider them as adding like a fraction. So 3 I'm going to consider as 1, 3 divided by 1. So to make the common denominator, I have to multiply and divide by this 2. So this becomes 3 times 2 is 6. So we have 5 by 2 plus 6 by 2. And now we have a common denominator. So we can add these two numbers. That is 5 plus 6 is 11 over 2. So therefore, you can write down this equation of the line as y equals negative half x plus 11 by 2. And this means option B is correct. Let's now find the inverse of this function. So we have the function f of x equals 5x minus 2. The first step in finding the inverse of the function is we replace f of x by y. So therefore this becomes y equals 5x minus 2. The next step, we interchange x to y and y to x. So let's do that. So I'm going to replace all x by y and all y by x. So therefore this y will become x and this y, x will become y. So therefore this becomes 5y minus 2. And in the next step, we have to solve for y from this equation. So I'm going to add 2 on both sides. So when I do that, I get x plus 2 equals 5y. And this implies I can solve for y by dividing by 5 on both sides. So therefore y equals x plus 2 divided by 5. Now we have to replace y by f inverse, and this is the inverse of the given function. So therefore, I replace y by f inverse of x, and this equals x plus 2 over 5. So we determine the inverse of the function, which is f inverse of x equals x plus 2 over 5. And this means option B is correct. Let's write the equivalent of this expression, that is x power minus 3 minus of y power minus 3. So I'm going to use the law of exponents and rewrite this expression in terms of positive powers of x and positive powers of y. So x power minus 3, this can be written as 1 over x power positive 3 minus of, and similarly y power minus 3 can be written as 1 over y power positive 3. So now we have to find a common denominator so that we can simplify this fraction. The common denominator is going to be x cube y cube, and this means we multiply the first fraction by y cube. So I multiply and divide this by y cube, and I multiply and divide the second expression by x cube. So then this becomes, the first expression is y cube times of 1 is y cube, divided by the denominator we have x cube y cube, minus of 1 times of x cube is x cube, divided by x cube y cube. We now have common denominator, that is x cube y cube and x cube y cube, which means we can subtract this numerator. So therefore this becomes y cube minus x cube, divided by the common denominator x cube y cube. And this means option D is correct. We now write this expression in factor form. So first I'm going to factor the GCF. The GCF of these two terms is xy. We have xy over here, as well as we also have xy over here. So I'm going to factor the GCF, that is xy. And when I do that, in the first expression, I'll be left with x cube. And in the second term, I'll be left with the term y cube. So therefore, we get xy times of x cube minus y cube. Now this can be further written in factor form using the difference of cubes. We use the identity x cube minus y cube. This equals x minus y times of, we correct this. This is x minus y times of x squared plus xy plus y squared. So this is the factored form of this expression x cube minus y cube. So therefore, this is the complete factor form of the given expression. So This means option C is correct.